I've been revising all night. Time to start my totally legit exam. Let's go. Turn it over. Question 1. Try this, dumbass. That's not nice. Get my pen. Nigga, what the f...
Plug. Oh my God! Baby, I'm flying with baby. Baby, I'm flying.
I don't understand this big ass equation over here, right? What you need to know about is the quantum wave function, or my niggas know about it. It's denoted as the Greek letter phi, and essentially, we know about wave-particle duality, right? Well, you better, because an electron is a wave and particle at the same exact time. That's what it means, right? So look at this nonchalant shit over here. This electron is represented by a wave, right? And now the shape of the wave mathematically is represented by the function phi of x, a function of x. For any input of x, it gives you an output according to this graph, right? But the question, what the fuck is waving, arises like my schlong in the preschool. Now, nigga one's interpretation of this, nigga one being Schrödinger, of course, is that the wave is a smushed up electron carrying a distributed charge. Now, that would make sense, right? But, right, fat ass over here, the double slit experiment would detect the distributed charge, right? But it does not do that. It detects the charge coming in all at once, right? I don't know why I did that. Like, so that just means that Schrödinger is just a fucking retard at this point. Now, that gives way for negative interpretation, right? Negative being born, of course. Now, what nigga 2 says that if you take psi of x and square it, what you get is the probability of the electron arriving at each point, right? Now, the probability over here is the highest because it's the highest peak. Now, the reason you square psi of x is you cannot have negative probability. This is a negative probability over here. It's something like negative 5%. You can't have a negative 5% chance of an electron appearing at an exact point. That's why we have to square it, right? And the way this wave function arises is that we shoot a bunch of electrons at a wall in the double slit experiment, like we're in Hamas or something. And essentially, we can graphically represent the location of each electron, and we can build our wave function off of it. However, a question, does one electron ruin it for the rest, arises because if you shoot an electron at a wall, the location that you shoot it at is, well, 100% chance of like housing the electron, right? Every other location is 0% of 0% chance of having the location, because the electron just like spikes up in probability to this singular point. Now, what? Just about from a lack of a because I don't know how to answer that question.
Do you have clinical
so I'm just gonna move on,
depression?
right?
Have you ever accidentally
That
broken
still
your
doesn't
mom's
answer the
favorite
question.
coffee
That
cup,
still
and when
doesn't
she found
answer
out you did it,
what the
she
fuck's
tied you
waving
to a
right
bed and
over here,
spanked you
right?
with a metal spatula? If
We
you
don't
said
know.
yes to any
We
of
still
these
don't know.
things, I
It's
don't
an
care.
unanswered question.
And to keep it a bean,
I mean, but no one
cares.
cares anyway, right? I was gonna do this cute thing where I like, but no one cares anyway. But I kind of forgot about it. Anyway, this is Schrödinger's equation, right? And we now understand that this C of x represents the quantum wave function. And on the next episodes, brings us to the next episode of Dragon Ball Z, where we learn about Dirac, Bra, and Ket notation. This is a C in bra notation, right? This is bra, this is Ket. And if you want to see me in a bra, you can just subscribe to my OnlyFans.
I've made a severe and continuous lapse in my judgment, and I don't expect to be forgiven.
Oh my God!